So at the beginning of every science class, we are obligated as teachers to teach you about the steps of the scientific method. So this will probably be a review for you, but it'll be a good review and we'll do some activities in class. So the scientific method is just a series of steps in order to investigate and understand and explain some natural occurrence that we observe. Okay? The steps of the scientific method, they start by making some sort of observation and stating what the problem is or what your observation is. And then a good scientist gathers background information about that topic so that they can formulate a hypothesis or an educated guess to explain why that problem is occurring or explain that observation. Okay? Then, in order to either support or not support their hypothesis, they're going to develop an experiment, okay, that will test their hypothesis. Through the experiment, we gather data, and then we can organize that data into charts and graphs and figures in order to analyze those results and make a conclusion. The conclusion for any scientific experiment is either that your hypothesis is not supported or that your hypothesis is supported. So if your hypothesis is not supported, then you're going to go back and you're going to gather more information. You're going to come up with some new explanation. If your hypothesis is supported, then you'll go back and you'll repeat your experiment over and over, or you'll publish your results, and then some other scientists will repeat your experiment in order to confirm your conclusion. So let's just kind of discuss a little bit about experimental design, and we're going to use an example involving The Simpsons. So let's say Smithers noticed that workers who drink Duff beverage on their lunch break staple fewer papers. So in order to design an experiment in order to link Duff beverage to the stapling of fewer papers, he's going to separate workers, two groups of workers, 50 workers each, into Group A and Group B. Group A will receive the Duff beverage and Group B will not. And then he will give them a task, all the same task of stapling papers, and at the end he counts up the number of papers that are stapled. Okay, so in this example, we have treatment groups, and not every experiment divides into two different groups like this, but in this example, we have the experimental group and the control group. The experimental group receives the treatment, so in this case, our treatment is the Duff beverage, so that would be Group A. And then the control group does not receive treatment. It's used as a basis for comparison, so that would be Group B, but does not receive the Duff beverage. Now, in the experiment, we have variables as well. So we have an independent variable, also now called the manipulated variable. And this is the variable that we think is causing some sort of effect on the group. We think it's the reason we're seeing or observing this problem. Okay? And so in this case, the Duff beverage is the independent variable. Okay? The independent variable is also what is controlled by the experimenter. Okay. Now the dependent variable is the thing that responds to the independent variable. So this is always the thing that is measured. So in this case, what we're measuring is going to be the number of papers. Now, of course, we also have controlled variables. So there's lots of things that were controlled. Both the groups are the same size. There was a random selection of workers. Okay, they were all stapling at the same time. So there's a lot of things that are then controlled and presumed to not be causing whatever the effect is, or the dependent or responding variable. So after we perform the experiment, we count up the number of stacks, and then we take that data and information and we put it into a data table like this, okay? And then typically we'll put it into some sort of chart that allows us to visually see very easily, although this is pretty easy to tell, but we'll look at a chart where we can visually see whether or not our hypothesis is supported or not, okay, or how our independent variable affects our dependent variable. Okay, so in this case I chose to use a bar graph, okay, and you can see that on the y-axis here we have the number of papers. So on the y-axis we have the dependent variable, the thing that is measured. And the reason we do that is so that you can just very easily see and visually distinguish whether or not it goes up or it goes down based on the treatment group. Okay. So on the y-axis, or on the x-axis, then we have the independent variable, either the gets the Duff beverage or doesn't get the Duff beverage. Okay, now the hypothesis originally was that Duff beverage decreases productivity or decreases the number of papers stapled. But we can see here that the group that got the Duff beverage stapled more papers, so we would say that our hypothesis is not supported by these results. Okay, so we'll be doing some examples similar to this in class and looking at analyzing graphs and things like that.